All right, so let's finally finish up section 5.2 by talking about parameters for binomial distributions. So by parameters for binomial distributions, this means we want to know about the mean, variance, and standard deviation. So back in the beginning of chapter 5, we looked at the mean and standard deviation for just any old probability distribution. And we saw that that took a fair amount of calculation sometimes. Fortunately, due to the kind of regularity of a binomial distribution, a fixed number of trials, a constant probability, the formulas are a lot simpler. So for the mean for a binomial distribution, it's going to be NP, where P was the probability of success and N is the number of trials. For the variance, sigma squared is N times P times Q, where again, N is the number of trials, P is the probability of success, and Q is the probability of failure. And then for standard deviation, we would just take the square root of the variance. So these formulas can help us calculate, again, decide whether some outcome is significantly high or significantly low. So let's see some examples. So here it says a survey found that 1 in 5 Americans visited a doctor in any given month. 10 people are selected at random. We wanted to know the probability that exactly 3 visited the doctor in the last month. We'll find the mean and standard deviation, and then we'll decide a question about significance. But let's start with just the probability first. So the probability that exactly 3 visited the doctor in the last month, that is a binomial problem. So out of 10 people selected at random, we want to know the chance that 3 visited the doctor. 1 in 5 Americans, that is a 0.2 probability. We need that to occur 3 times. Then if there's a 0.2% or 20% chance that somebody visited the doctor in the last month, then there is a 80% chance that they didn't. And we need that to occur with the remaining 7 people. So let's go ahead and calculate that. All right, so going through the details of the calculator, it worked out to be about a 20% probability. Okay, so next we need the mean and standard deviation. So the mean is NP. So mu will be just NP. Here, N is the number of trials, which will be the 10 people selected. The probability here is 0.2. So 10 times 0.2 is going to be 2. And then for the standard deviation, it will be the square root of NPQ. So square root of 10.2 0.8. So let's go ahead and calculate that. That's about 1.2, 1.3 after we round it for the standard deviation. Okay, so now it says in a group of 10 people, it says 5 visited the doctor in the last month. We'd like to know if that's significant. So we should find out the probability of that occurring. So let's do that. All right, so in a group of 10 people, 5 visited the doctor in the last month. We want to know if that's significant. So let's see what we would consider to be typical. So what's typical would be values within 2 standard deviations of the mean. So the mean was 2. And then if we go mean plus 2 standard deviations, that'll be 2 plus 2.6. Which is 4.6. And then we could go mean minus 2 standard deviations, but that's not relevant for this question here. 4.6 people would be the outer limit of what you would consider non-significant. So having 5 people visit the doctor, that is significant. it's more than 2 standard deviations above the mean. One more example and then we're done with this. So here it says in Pittsburgh, Pennsylvania, about 57% of the days of the year are cloudy. We want to find the mean and standard deviation for the number of cloudy days for the month of June. June has 30 days, right? And then we want to know during 1 month of June, would it be significant to have only 12 cloudy days? So let's compute. So mean first is going to be NP. There's 30 days, out of which 57% are cloudy. So then we should expect about 17.1 cloudy days. Standard deviations, the square root of NPQ. So square root of 30 times 0.57, probability of getting a cloudy day, and then times 0.43, probability of a not cloudy day. So that's about 2.7. So the mean is 17.1, the standard deviation is 2.7. We need to figure out if 12 cloudy days is more than 2 standard deviations below the mean. So mean minus 2 standard deviations, 17.1 minus 2 2.7s. That's 11.7. Okay, so no, it wouldn't be significant. "11 cloudy days would be significant, but 12 is not." All right, so I hope that helps. Let me know if you have any questions, and then we'll be going on to section 5.3 tomorrow.